Assalamu alaikum everyone. My name is Mohammed Noman Adam and welcome to my YouTube channel. So today we are starting with random variable exercise question from chapter number 3 of Walpole book. So here we will focusing on problem 3.12 and working through the solution step by step. If you don't know about the random variable, there's a link in the description. You can go there and listen to that lecture. So by the end of this video, you will understand how to solve the random variable problems with full of confidence. Okay, so here I have written some formulas on right hand side. So you can see to find the probability mass function from the cumulative distribution function. I mean what? If you look at the first formula, this one, the first formula, the probability of capital X is equal to small x. So this is the probability mass function of a single value. This is equal to the cumulative distribution function on X minus the cumulative distribution function just before X. So basically, whenever you have given the cumulative distribution function, I mean the CDF is given and you are asked to find the probability of a single value. So you can see the probability of a single value. So how you can find? You just write the probability, I mean the CDF of X minus CDF of X minus, right? So this is the very important formula for discrete random variable. And remember, this f of X is representing the cumulative distribution function on X, and if fx minus represent the cumulative distribution function just before X. And similarly, you can see the second formula, and the second formula is the capital F of X. I mean, this is the definition of cumulative distribution function, and this is equal to the probability X is less than equal to X. This is not strictly. So here I can write probability X is less than equal to X. And this is, that the definition of cumulative distribution function. And the third formula we can see here, whenever the random variable lies between two constant values, so we can write f of b minus f of a. And the last formula is for conditional probability. So you can write the probability of A given B. The B event has already occurred. So this is equal to the probability of A intersection B divided by the probability of B. So we will use all these formulas here. Okay, the question is, an investment firm offers its customer municipal bond that mature after varying number of years. Given that the cumulative distribution function of T, the number of years to maturity for a random selected bond is given by this capital F of T. And you can see here we have given the CDF. This is basically the cumulative distribution function for the random variables. So here we are going to find the probability of capital T is equal to 5. The capital T is strictly greater than 3. And in the third part, we are going to find the capital T is my random variable is lies between 1.4 and 6. And the last part, we will use the conditional probability formula. So the first part is what? So we will find here the probability of capital T is equal to 5. So this means you can see we are going to find the probability on a single value. So here we will use this formula. The probability is capital X is equal to small x, capital F of X minus F of X minus. So because we are going to find the probability of T is equal to 5, so this means I can use this formula, the F of 5 minus F of 5 minus, right? So what is meaning by 5 minus? You remember the meaning of this one is, so because we are looking here, the CDF, I mean the cumulative distribution function just before 5, right? Just before this 5. So you can see here, so I can write like f of 5, the value on 5 minus, what is meaning by 5 minus? So CDF just before 5, you know that. So we can write here. So CDF just before 5 is f of 4, right? Before 5, we have this value. So I can check this values here. So what is the value of f of 5? So you can see, so 5 is here. So the 5 is lies in this interval, right? Because the 5 is here, T is greater than equal to 5 and less than 7. So this means I will pick this value 3 by 4. So this means the f of 5 is equal to this 3 over 4 minus just before 5. I mean I required a 4 value. So you can see here the 4 is lies in the third interval because T is greater than equal to 3 less than 5. So this means I will pick 1 over 2. So this means I can replace here 1 by 2. So this implies when you calculate this expression, you get 1 over 4. right? So in the second part, we are going to find the probability of capital T is strictly greater than 3. So in the second part, so we will find the probability of capital T is more than 3. So here we have a lot of method to solve this type of expression, but I will give you an idea about this one. So this is basically equal to, I can write 1 minus the probability is, I can write T is less than equal to 3. So you can also remember this formula, and I will give you an idea about this one, how I am writing this one. So let us say there is a number line here, you can see, and this is minus infinity, and here is positive infinity, right? Imagine a real line. So, and this real line is basically representing the all possible values of cumulative random variables on X. So let's say mark a point 3 here, right? So you can see we have two intervals. The first interval is, we can see here, minus infinity to 3, and the second interval is 3 to infinity. And you remember, basically we know that, so basically that these two intervals cover the total real line, okay? And you know that if you're looking here, the total real line, the sum of probability is always equal to 1. So I can write like this one. So you can see in the first interval, so can I say here, this is the probability of X is less than equal to 3. Only this portion, I'm talking about only this portion, right? Probability of X is less than equal to 3. If you look at the second one, so I can write here the probability of X is strictly more than 3. I'm talking about this one, right? So you can see here, because less than equal to 3 this area, and greater than 3 is this area. So this means I can write here, so probability of X is less than equal to 3 and plus probability of X is strictly more than 3, this is equal to 1. Why? Because you know that the sum of probability is always equal to 1. You can see here. So now I can write here probability of X is greater than 3. So you can write the probability of X is strictly more than 3. So this would be equal to 1 minus the probability of X is less than equal to 3. So this is the very important formula. You can see here, you can use this formula directly, right? You can generalize this formula like this one. Whenever you have this expression, like the probability of X is greater than, let's say, some value small x, or let's say I'm using here some constant like a. Okay, so you can directly write this one. So I can write the probability of X is less than equal to small a, right? So this is the very important formula. You can use this formula, okay? So that's why you can see here, whenever the probability is t greater than 3, so I can write 1 minus the probability of t less than equal to 3. Again, I rewrite this expression here. So this is the probability of t is more than 3, and this is equal to 1 minus the probability of capital T is less than equal to 3, right? And you know that in cumulative distribution function, we have already learned about this one. So basically we know that what is the value of capital F of X? I mean, what is the formula of capital F of X? We know that I can write probability of X less than equal to X. So this means if I'm writing here the probability of T is less than equal to 3. So this means I can write here f of 3 by using this formula, right? So this means I can write 1 minus f of 3. Okay, what is the value of f of 3? So you can see your interval. Where is the f of 3? Where is the f of 3 lies? So you can see the 3 is here in the second interval. So you can see here the 3 lies here. So I will pick this value 1 by 2. Right, so this means f of 3 value is equal to 1 over 2. So after calculation, my answer is 1 by 2, right? This is my second part. In the third part, we will require the probability of 1.4 is less than t and less than 6. So in the third part, we are going to find the probability of 1.4 is strictly less than t, and this is less than 6. Right, and we know about this formula also. We know that because we know very well how to calculate this expression. So this is basically, you know that I will use this formula, this one. Whenever the random variables lies between a and b, you can see here, okay? When the random variable is lies between a and b, so you can apply this formula. So I'm using this formula here. So because my random variable is t lies between 1.4 and 6, so this means I can write this would be equal to f of 6 minus f of 1.4. So look at the value of f of 6. Where is the f of x? F of 6 is lies here. So you can see the f of 6 mean, you can see the f of 6 is lies here in the 1, 2, 3, 4th interval. The value is 3 by 4. So I can write here 3 by 4, right? And minus, what is the value of f of 1.4? So you can see where is the 1.4? So 1.4 is lies in the second interval because the t is greater than 1 and less than 3. So this means 1.4 is lies here. So this means the value is 1 over 4, right? So when you calculate, you can easily get this answer, which is equal to 1 by 2. So this is my part number C. And the fourth part is very important here. So we are going to find this expression. So first I will write here. So now we require the probability of this capital T is less than equal to 5, given that the T is greater than equal to 2. So here, this is the condition probability question. You just consider like this is your A value and this is like B value. And you know that what is the formula for conditional probability? We know that the probability of A given B, this is equal to the probability of A intersection B and divided by the probability of B. You just consider this is A and this is B. So if you apply this formula here, so how you can write this one? So you can write the probability of A intersection B mean, you can write like the T is less than equal to 5, this value, and we are taking the intersection mean the common points. So the T is more than equal to T, and we are dividing by what? We're dividing by the probability of B. So I can write here the probability of T is greater than equal to T, right? Okay, so here we require the common points between 5 and 2. So let's draw a real line here. So let us consider this line. This is my real line here. So I require 2 points, 2 and 5. Let us say here is 2 and there is a 5 here, right? Okay, what is meaning by T less than equal to 5? T less than equal to 5 mean this area, right? I'm using here this area. T less than equal to 5. This is my T less than equal to 5. Right, T is less than equal to 5. And now the second thing we require, T is greater than equal to 2. So this means we are talking about this portion, T is greater than and equal to 2. So now we require the common between these two. And what is the common value? So you can see the common value here. I'm using this red color. This is my common value from 2 to 5, right? You can see here there's a common portion between 2 to 5. So what is mean by this one? So you can write here, you can write the probability of this portion. We can write here 2 is less than equal to T and this is less than equal to 5, right? You can see here because you know the common portion between this one is from 2 to 5. And now you know that in my denominator the probability T is greater than equal to 2. So I will apply this formula again, this one. So because there is a equality sign is also here, so I can write 1 minus the probability of T is less than 2. Okay, fine. And we know very well this formula. We have already learned what is the probability of A like less than equal to X and less than equal to B. So how we can write this one? The probability of B minus A. So this means I can write this is equal to F of, my second value is 5, F of 5 minus F of 2, right? Because the second value minus first value and dividing by 1 minus, you know very well, this is a definition of CDF, probability of T less than 2. So I can write this is the value of F of 2. So just I will put all these values here. What is the value of F of 5 and F of 2? So you can see here, where is a 5 is like, where is a 5 here? So F of 5. So you can see the F of 5 is here in 3 by 4 because T is greater than equal to 5 and less than 7. So this means there is F of 5 is here. So we will put this value 3 by 4. And where is value of F of 2? So you can see the F of 2 value is here, right? Because the 2 lies between 1 and 3. So I can replace 3 by 4 minus 1 by 2. So, sorry, 3 by 4 minus 1 by 4 over whole divided by 1 minus, what is the value of f of 2? We know that this is also 1 by 4, right? When you calculate this expression, you can see your numerator, this will give you 2 by 4 over, you can write this will be 3 by 4. So your answer is, the last answer is 2 by 3. I hope you understand this lecture. Thank you very much for watching this video.